Okay, we've got x squared minus 18x plus 81 equals 0. So remember when you're talking about factoring, and it applies to solving these problems, you're going to have to get it set equal to 0, which in this case it already is. And when you look at what we have to work with here, we can do this one without making use of the tutor to show the steps, because the greatest common factor is 1, so we can work with what we've got here. And what I see is that since there's a 1 out front of this, x squared, all I have to do is think of two numbers that multiply to give me 81 and add up to negative 18. So when you start listing the factors of 81, we've got to think about double negatives, right? The minus plus situation, we're going to have something that's the same sign to give us a plus here, but they have to both be minuses to get this. So it looks like minus 9 and minus 9 would multiply to give you 81 and would also add up to negative 18. So when you're doing this out, of course you can do it on paper, you make a list, you get all the factors. I'm trying to talk it through because I just have the screen to show you right here. So minus 9 and minus 9, and because it's just the basic type, the lead coefficient of 1, I could just say I definitely expect it to be x out front. There's a minus 9 and a repeat factor of x minus 9. Okay, so this is going to be step 1 once it decides to submit for me. There we go. And remember that step 2 will involve taking each one of those factors and solving, but setting each one equal to 0 and solving. Since it's the same factor twice, we just need to do it one time. There's just going to be one solution. So x minus 9, if we set that equal to 0 and solve, add 9 to both sides, we'd end up with 9 as a solution. Okay. Alright, here's one that's, a little bit more involved. 25x squared plus 30x plus 9. There's no greatest common factor that's clear to pull out other than a trivial 1 value. And since there's something other than 1 out front, we're going to have to fish out combinations using both first and the last value. Remember, there's two methods to do this. Either what they call the AC method, where you multiply the outside values and then try to match up to the middle, or you get the combinations for the front and back and do a trial and error. Let's go to the tutor mode. They'll prefer this AC method, which is okay. Or actually, to tell you the truth, they try to recognize that it's a perfect square pattern. When you're going through all these problems, it's perfectly fine to deal with this the way the other problems were done. They recognize that this is the same as, the front position, they're calling m squared. You're recognizing that this is a 5x that was squared to give you 25x squared, and a 3 was squared to give you 9. But really, this isn't the way to do this problem, in my opinion, because when you approach these problems, you're not going to necessarily recognize right off that this is a perfect square. You might, but you could just multiply the outside numbers together, try to come up with something that would multiply to give you that, but then add up to 30, and work it like the other problems. You'd probably do better to just kind of have one method, either that or trial and error, have one method and go through all these problems like that. But anyway, to play their game, if you kind of see it that way, 5x and 3, it's a repeat plus pattern, so 5x plus 3, and then 5x plus 3 again. Okay, so 5x plus 3 is the repeated pattern, it's the repeated factor, and so we only need to take one of those, set them equal and to 0, and solve. So if I took 5x plus 3 and I set it equal to 0, I'd have a little equation where I'd subtract 3 from both sides, and then I'd end up dividing both sides by 5, and your final answer would end up being negative 3 over 5. So you can work that out on paper, see what it looks like, make sure. If you're not sure, you can go through the tutor mode. Yeah, let's see if we can find anything else. This looks like another hefty one here. I don't mind doing this one out, but I think you've seen a few of these now. So, well, maybe we can do one more. Let's see. I just don't want to skip any of the important types here. Alright, so if you had this type right here, you could say 56x squared plus 31x plus 9 equals 6. I need that set equal to 0. So if I were to subtract 6 from both sides, I'd have a 3 in that last position, and it would be set equal to 0. Let's see what they show us in the software. Okay, so they want us to put it in, subtract 6 from both sides like I just said. They say, what would you have? Oops. I'd have 56x squared plus 31x plus 3 equals 0. Okay? And then they remind us that their method of choice is that you multiply the outside numbers together. 56 times 3 is 168. Can we think of two numbers that multiply to give us 168 and add up to the 31 that's in the middle position? So let's think of combinations. If you were to try to multiply to get 168 and add up to 31, you're not going to be able to necessarily do that in your head, but you can systematically test things that will divide into 168. You could start with 1, 2, 3, 4, 5, 6, 7, keep going if you want, until you find something that works. Sometimes I'll say, take a look at that middle number, kind of like, you don't necessarily need to start with 1, maybe you start with something like 4, or 10, and see if you get something bigger or smaller than the middle number when you find factors. 168, if you tried, say, like divide in 4, you'd get 42. 4 plus 42 is 46. A little too big. So I keep increasing the smaller number. That's going to decrease the bigger number, and usually it will shrink it down until we get a match, if this is factorable. I tried 7. If you divide 7 in, you get 24. 24 times 7 is 168. 24 plus 7 is 31. So those are the numbers that are going to work for us. And if you find a combination that works, this is factorable. Okay, so 24 and 7. Alright, so they're saying now rewrite the middle term 31x with those numbers as coefficients in front of the x values. Added up, we'll get 24x plus 7x. Alright, so factor by grouping. If I took 56x squared plus 7x, factored out a greatest common factor, I'd have 7x. And inside, when I divide that away, I'd have 8x. And if I divide 7x from itself, remember that that's still a plus 1. You don't want to lose that value. Second pair, 24x and 3, I can factor out a 3. That's going to divide away and give me 8x plus 1 again. This is the pattern that will always happen with this method, is that you're going to end up with the same thing here and here, if it's going to work, or if you've done it right. So 8x plus 1 is what you have in the first set of parentheses. After you remove that, divide it away, 7x plus 3 is in the other set of parentheses. Okay, so those are our factors. I only have moments left before I run out of time here, so just so you know, negative 3 over 7 is what you'll get when you solve the first factor set equal to 0, and negative 1 over 8 will be your answer for the second one.